Welcome, dear students. Now we discuss numerical methods, paper CC-14, semester 6, CBCS, B.Sc Mathematics Honors, 2024, Unit-1. The question paper 24 is the Unit-1, 1 to 10 marks. Question A to J as the solution of this question paper for this Unit-1. Question 1A, how many significant digits does the floating point number this have? Correct option is 2, 4. Because in this number this 4, 3, 2 and this tailoring 0 are significant, but this leading 0, this 0 is not significant. So there are 4 significant figures, 4, 3, 2 and 0. Next, question B, the product of mu delta is given by, correct option is 4, because we know E is the shift operator, E fx equal to f of x plus h, and the central difference operator delta, the delta fx is equal to f of x plus h by 2 minus f of x minus h by 2, that is e to the power half minus e to the power minus half fx. And the average operator mu, so mu fx equals to half of into f of x plus h by 2 plus f of x minus h by 2, that is half of e to the power half plus e to the power minus half fx. So mu delta is equal to this plus this into this plus minus this, so a plus b into a minus b, so a square minus b square whole divided by 2, that is e minus e inverse by 2 whole divided by 2. So correct option is 4. Next question C, if fx equal to x square, then the second order divided difference for the point x0, x1, x2 will be, correct option is 3, 1. Now first order divided difference, this is the x0 and x1, f of x0, x1, this is equal to fx1 minus fx0 by whole divided by x1 minus x0, that is here fx equal to x square, so x1 square minus x0 square whole divided by x1 minus x0, that is this x1 plus x0 into x1 minus x0, cancel from numerator and denominator this, so x1 plus x0. And similarly we get a divided difference for f of x1 x2 equal to x2 plus x1, and the second order divided difference, this f of x0, x1, x2, this is equal to f of x1, x2 minus f of x0, x1 whole divided by x2 minus x0, and this and f x1, x2, this is equal to x2 plus x1, and f of divided difference of f of x0, x1, this is the x0, x1 plus x0, so cancel x1, x1, so x2 minus x0 by x2 minus x0, so this is equals to 1. Correct option is 3. Next question D, the error term committed in computing derivatives, this correct option is 4, and this Rn plus 1 dash x, this equal to omega dash x, if n plus 1th derivative at the point xi whole divided by n plus 1 factorial plus omega x, if n plus 2th derivative at the point xi1 whole divided by n plus 2th factorial. Now error in polynomial interpolation, we know this is the remainder term or error term, this Rn plus 1x, this is equal to x minus x0, x minus x1, x minus xn into f n plus 1th derivative at the point xi whole divided by n plus 1 factorial, and this products in n plus 1 terms, products of this n plus 1 terms, this is called omega x, and this equal to this, and We know this divided difference, this fn plus 1 xi divided by n plus 1 factorial is the f of x, x naught, x1, x2, xn. The divided difference is this. We know this relation. So Rn plus 1 dash x equal to omega dash x, and f of x, x0, x1, xn plus omega x into derivative of this. So this is equal to f x, x0, x1, xn. Now the divided difference, this f of x0, x1, xn is equal to fn xi whole divided by n factorial, and f of x, x0, x1, xn is fn plus 1 xi whole divided by n plus 1 factorial. And this f x here there are 2x, this x, x0, x1, xn, this fn plus 1 xi whole divided by n plus 2 factorial. So this is equal to omega x f n plus 2th derivative at the point xi1 whole divided by n plus 2th factorial, where minimum x, x0, x1, xn less than xi, xi1, maximum of this, and omega s is this. We can find this alternative form of this. Actually, so correct option is 4. This we can find the alternative form, this omega dash x fn plus 1 xi whole divided by n plus 1 factorial plus omega x f n plus 2th derivative at the point xi whole divided by n plus 1 factorial, and xi a function of x, so xi dash x. And reference, you can consult this book, Numerical Analysis with Algorithms and Programming, by Professor Santanu Saharoy, CRC Press, 2016. Next question, E. The error committed in numerical integration of the function fx equal to this cubic function by Simpson 1/3 rule between -1 to 2 with 2 subintervals is this. Now we know the error term in Simpson's 1/3 rule is given by E Simpson's C4 composite. Error term is approximately equal to minus b minus a h to the power 4 by 180 f fourth derivative at the point xi, where a less than xi less than b. And in this case, function fx equal to 4x cube plus x square plus 2x minus 1, and the polynomial of degree 3, fourth derivative of the polynomial of degree 3 is 0. Fourth derivative is the f of fourth derivative at the point xi. Here this degree cubic polynomial, so fourth derivative is 0, hence this error term obviously 0. Obviously 0. The degree of precision of Simpson 1/3 rule is 3. This means it can integrate any polynomial function of degree 3 or lower exactly. There is no error for the polynomial, maximum polynomial of degree 3 or degree 2 or degree 1. There is no error term. So here is the redundant. This is the value of a and lower interval, lower limit and upper limit, the 2, b equal to 2, a equal to 1, and 2 subintervals is not necessary to calculate this the error term, because this fx is a cubic polynomial. Yes, hence the correct option is 1. Next question, F. Consider the equation x plus 1 into x minus 1, x minus 3 equal to 0. If the bisection algorithm is applied to the initial interval minus 4 to 4, how many roots of the given equation will you be able to compute this? Correct option is 2. Clearly, there are 3 roots here, minus 1, 1 and 3. All lie within this minus 4 to 4. But bisection method works by repeatedly having the interval and selecting the subinterval where a sign change occurs. It can only isolate and compute one root at a time. Now, for this, you can choose fx equals to this polynomial, this cubic polynomial, and a equal to minus 4, b equal to 4. This by section table, this A, B, F A, F B, and C is the midpoint, A plus B whole divided by 2, and corresponding value of F at the point C. So choose A equal to minus 4, B equal to 4. F A equal to this minus 105, F B equal to 15. So F A into F B less than 0. And C is the midpoint of this. At this point C, this is equal to F C equal to 3. So F A is negative, here F C is positive. So change this value of B, because B is positive here, value of F at the point B is positive. So change only the value of B, put here value of C here, so 0. Next calculate this, C is this, value of C is minus 2 here, second step, and this is the value of F C is equal to minus 15. So change the value of A by new C. So this minus 2 0, and this midpoint is minus 1, and the value of F C equal to 0. Hence x equal to minus 1 is a root of this equation Fx equal to 0 in the closed interval minus 4 to 4, although there are another two roots, x equal to 3 and x equal to 1 in this interval. So correct option is 2. This actually we have one root by this bisection method. Question G. Consider the fixed point iteration xk plus 1 equal to gxk with gx equal to x by 3 plus 4 by 3x. Which root finding problem is this equivalent to this? Correct option is 1, that is x square minus 2 equal to 0. To find the equivalent root finding problem, set x equal to gx and rearrange the equation to the form fx equals to 0. Now x equals to gx, that means x equals to gx means x by 3 plus 4 by 3x. This implies x minus x by 3 equal to 4 by 3x, and after simplification we get x square equal to 2, that is x square minus 2 equal to 0 is the correct option. Question H. In the Gauss elimination method for solving a system of linear algebraic equations, the row reduced phase of the coefficient matrix leads to a upper triangular matrix. Correct option is 3, because Gauss elimination, the row reduced phase of the coefficient matrix transforms it into an upper triangular matrix by row reduction method. And this row reduction method, actually we deduce this into a row reduced echelon form. Actually this transform this matrix the upper triangular matrix, and this process is also called triangularization method. So correct option is 3. Next question I. Consider A, this 3 by 3 matrix, and x tilde naught, this is the column matrix 1 0 1. The first approximation to the eigenvector corresponding to the dominant eigenvalue using power method. Now A into x tilde naught, this equals to A, this x tilde naught. So by matrix multiplication 6 4 12, the largest numerical largest value is 12. So dividing the each elements of this column vector by 12, so we get 12 into 1 by 2 1 by 3 1, and this called 12 is the first approximation of the largest eigenvalue lambda 1, and this is the corresponding eigenvector, this x tilde 1. Hence the first approximation to the eigenvector corresponding to the dominant eigenvalue using power method is x tilde 1, that's equal to half 1 by 3 1. So correct option is 3. Question J. Using Euler's method to approximate an ordinary differential equation, you obtain the difference equation yj plus 1 equal to yj plus hayj, where a is a constant and h is the time step. What is the ordinary differential equation? Correct option is 1, dy dt equal to ay. Because we know Euler's method approximates dy dt equal to f dy. With the corresponding difference equation, this yj plus 1 equal to yj plus h into f of tj yj, or we can write yj plus 1 minus yj whole divided by h equal to f of tj yj. Actually this yj plus 1 minus yj whole divided by h represents this dy dt. Now we have yj plus 1 equal to yj plus h a yj, or this yj plus 1 minus yj whole divided by h equal to ay. So this is the dy/dt, and this is equal to ay. So correct option is this, dy/dt equal to ay. Correct option is 1. And note that here the marks is only 1, so you can get 1 mark for choosing the correct option. Explanation is not necessary for this. Thank you.